Today we have a set of extremely interesting talks. The first one is by Renato Figueiredo, who is from the University of Florida and a member of the Future Grid team. He's in charge of education and outreach and training for Future Grid. And he's going to tell you about appliances and virtual networks and virtual clusters and things like that. Thank you very much.
Thank you, Jeffrey. I hope you all can hear me well. So, yes, I'm part of the Future Grid team at the University of Florida. I'm currently in Amsterdam giving this presentation remotely to you. And what I'd like to talk about today is a little bit of technology that is available in clouds and their uses in education in the context of Future Grid. So I'll begin with a discussion on virtual appliances and then how to put virtual appliances together to form virtual clusters, and then using these clusters to support educational use cases, in particular in Future Grid. So I'd like to start with a discussion on appliances, and the technology part of the presentation here, I will focus on virtualization, and the notion of appliance is one that arises when you have virtual machines available to run in the cloud. And the contrast with the physical appliance, if you look at a physical appliance, you have an instrument or a device that has a particular user function. In the case of a software or hardware appliance, even, you have things like your TiVo type device or your network router, and they're basically computers packaged together to perform a specific function. Now, a virtual appliance has a similar goal of being a piece of software now that is able to accomplish a specific goal. And virtualization is a technology that enables virtual appliances. And the key idea here is that virtualization allows you to package all the software that you need, including the operating system, device drivers, libraries, and applications and configuration, everything together into a virtual machine image. And once that is done, it's very easy to instantiate this virtual appliance on different types of hardware, in a cloud provider or in your own desktop. So a virtual appliance has no hardware. It's just a big image with the configuration of a virtual machine, and it can be instantiated on hardware. I'm not getting any audio feedback. I just wanted to confirm that people can still hear me. Can somebody just sound off? Yes.
We're listening in Michigan.
Okay, thank you. So here's one example of a virtual appliance. Let's say you want a web server, and you need Linux and Apache and MySQL and PHP. So you can put the installation of your Linux distribution with Apache and the version of the software that you want, configure it so you have a plug-and-play type system for a web server. And if you package this in a virtual machine image, then you can deploy this on machines that have software like VMware, VirtualBox, or KVM. And if you do this multiple times on multiple machines, you get multiple web servers. Now, one issue with appliances is they solve one problem very well, which is the problem of managing software configuration and dependencies. You allow the person who's setting up these virtual machines to be in complete control of what the software is going to look like. But if you have applications that require multiple machines to work together towards a goal, so if you're doing an MPI parallel processing job or Hadoop or Condor, then you just need beyond a single virtual appliance. You need a cluster of virtual appliances. And that requires an additional layer of virtualization to make it work so that virtual machines, virtual appliances can talk to each other. So that's at the core of what I'm going to talk about today, the technologies that enable this to come together, and then again, the uses in education. So continuing the example of web servers. Multiple web servers can be completely independent from each other. They don't need to necessarily communicate. If you package everything together, the database and the application server, etc., the machines are independent. But again, if you're running applications that are clustered, applications need to communicate. So you need a network stack communicating, connecting appliances together. And I'm going to focus here on the TCP/IP network stack because that's one that's widely available, and clustered software tends to work well on top of TCP/IP. But the ideas here can be generalized to other types of networking as well. But if you're thinking of middleware like Condor, Hadoop, MPI, you typically are looking at middleware that expects the machines that form a cluster to be part of a local area network, in which machines get assigned addresses and are able to communicate with each other without having to worry about routing, network address translation, firewalls, etc. If you have things like that in between your virtual appliances, you may not be able to have your software to work properly. So what we're looking at here then is to support virtual clusters in a cloud environment, that we have not only the virtual machine monitor, which gives us this ability to create virtual appliances, but you also have a layer of virtualization at the network level. So in this example, what I'm showing is, if you look at the lower plane, the blue plane, you have 3 domains, and they are connected, in this case, by the public internet, a wide area network. And on top, you have multiple virtual infrastructures, and these could be virtual clusters spanning across multiple domains. They could be within a single domain, but if you have network virtualization, you might actually be able to expand your cluster to go beyond a single site. And the idea here is that if you look at the example of the red plane V2, you have 8 nodes connected by a virtual switch, and these should look like they belong to the same local area network, even though they are in 2 or 3 different domains, and they may have a firewall or network address translation in between the nodes that are connected to them. So I'll talk about some of the technologies that are available to create these virtual clusters and their uses, again, in education. So what are some of the applications of virtual clusters and virtual networks? A couple of examples that are interesting. One is cloud bursting. So suppose you have a computer cluster on your local area network, and that cluster has limited capacity to run jobs. And you have more work than your capacity currently can provide. So one approach that you can take is to go to a cloud provider and buy virtual machine cycles, run virtual machines, and if these virtual machines happen to connect back to your enterprise network, this can be done in a way that looks as if you added resources to your local area network. But these happen to be external resources that connect through a wide area network. But if you have this notion of a virtual network, it's a dynamic cluster, essentially, that you have a static component on your local area network, and the dynamic component is provisioned on demand, and you pay as you go. So this typically works one enterprise farming off jobs to a provider like Amazon EC2, for example. Another example is, suppose you have now a group of people who are working together on a federated cloud environment. So now you have multiple institutions that have their own private clouds, and let's say that they share projects that would like to make use of resources that are common through this federated environment. So with virtual networks, you could now deploy virtual machines on different resources of this federation, and again, once connected, they would be perceived as if they were part of the same logical virtual network.